continue my continue the talk about the same region as my colleague Dr. Shi talked about. So I hope she set a very good background for our research area. But I will talk about the surface urban heat island, the diurnal cycle, and the seasonal variation with the geostationary satellite data based on this local climate zone concept. My talk will be divided into four parts. First, I will give a brief background. First of all, my my research background is undoubtedly this global climate change and also the fast expansion of the urban areas, which will cause confound changes to the urban surfaces, most notably the famous urban heat island effect. And we just see in the past work that UHI will cause a lot of impacts, adverse impacts on the various aspects of human life. So I will not repeat here. There are the introduction of the LCC in 2012 changed a lot, and it provide the consistent standard to quantify this urban heat island effect in various cities. So we will just use this, and you can see that ever since that time, the UHI study using this RCC framework has greatly increased, and up to the 2019, you can see the studies, the number of the studies has greatly increased. And I believe that if you continue the statistics, you can see the number even more. This we only show that using the satellite data to and the LCC framework to study the SUHI. But previously, most the SUHI studies using this satellite data and the LCC framework focus on this polar orbit satellites. That means the frequency of revisiting is limited. Say the MODIS, maybe the two satellites will overpass the same position maybe four times a day, and the Landsat, it will revisit the same place every 16 days. So the trade-off between this spatial resolution and temporal resolution makes that people most focus on those the satellite passing time. So the diurnal cycle have to resort to some other models, the temperature diurnal model, something like that. I can't remember exactly the name. So without using the directly observed data to form the diurnal cycle. So the geostationary satellite data will offer this high temporal resolution. But yes, the trade-off is still there. The high temporal resolution comes with low spatial resolution. So we will use the Fengyun 4. Fengyun means basically the wind and cloud. So FY4A geostationary satellite located at 104.7 degree east. So we will use that data to study the diurnal and spatial cycle of the surface urban heat island effect in our region. We will show that the data itself and first the research area, just like Dr. just talked about. We are in this so-called previously it was called PRD, the Pearl River Delta, because we have this Guangdong, Hong Kong, and Macau as a delta. Now it's expanded to this to include 9 cities from Guangdong province and the 2 special administrative regions, Hong Kong and Macau. So we show in this map. So it's a region with a highly developed economy and high urbanization level, and it's also a densely populated area which experience very strong UHI impact during the past decades. So it's an ideal place for us to study this urban heat island effect. So we created the LCC map based on the UDAPT method using both Landsat data and also the Sentinel data and some building height data. So we trained the model using more input features to get the better accuracy of the trained model. And to match the LCC data and land surface temperature data from FY4A, we have to resample the LCC to the 4 kilometer spatial resolution with this dominance method. So that's just some snapshots of the field of this resampled LST data, land surface temperature data from this satellite. So we can see there are many missing points. The white point, except those oceans in the lower half, other part, if that place is white, then it's missing data. So there are a lot of missing data, and the missing condition is different for different times. So statistically, we make this heat map to show how complete for each pixel or each LCC type. You can see that most of the time during the different seasons, most time the daytime has more missing data, while during nighttime the data is more complete. And across different LCC types, the situation are all more or less similar. No much change across different LCC types. So for the data, before our analysis, we have to do some pre-processing. We remove those obvious outliers and also filter those pixels with high terrain, more than 150 meters, because the major cities in this area are along the coast, so they don't have high terrain, so we just keep the terrain difference as small as possible. So after the pre-processing, we only have these points, pixels for analysis. Of these pixels, the LCC9 has the most numbers, and others are just around almost the same, not too much difference. To understand the surface urban heat island intensity, we calculate different metrics, basically this 6 metrics. The results, we show that the diurnal cycle of the surface urban heat island intensity based on the LCZ as a reference, the LCCD as a reference, which is sparse vegetation. As you can see that for each the intensity for the different LCZ has quite similar diurnal cycle of the surface urban heat island, but with some are different in different seasons. Like in the LCC9, the seasonal variation looks like quite high, and the on the seasonal scale, the JJA, that means the summer, has the highest surface urban heat island intensity, with followed by this autumn SON, and the winter the DJF has the lowest value, and then the seasonal difference of all LCZ are higher during daytime, especially during the daily peak, which is about 13 or 14 hours of the day. And seasonal difference are mostly about 0.5 K, and during nighttime, the difference are much lower. This is across different seasons. The difference in surface urban heat island is quite similar across different LCC types. And the LCC2 has the highest urban heat island intensity, while the LCC9 has, I think, has the smallest and is negative in most seasons. Uh, when we use different reference, say we use this LCCA, means dense trees or the forests, we can see much different patterns. First of all, the magnitude of the surface UHI intensity is quite high, much higher than when we use LCCD as reference. And there is no negative UHI intensity in this case. Uh, then we check the difference between LCCD and LCCA, and we find that it's because that difference in different seasons, which cause the difference in our observed surface urban heat island intensity we talked in the previous slides. So the matrix is we just talk about this maximum UHI time is just about 13 and 14 hours during the day, but the minimum surface urban heat island intensity, the timing is varying. It's in the middle, the two figures. The spatial distribution mostly just coincide with this urban development, but we haven't completed the analysis yet, as well as this mechanism of the surface urban heat island formation. So that will be our next step. So with this, I will stop my talk and thank you for your attention. Thank you.